This is for Year 12 Specialists, the 2015 Complex Numbers and Vectors SAC 1 Work Solutions. Okay, question 1, A is finding unit vectors, B is finding scalar resolutes and also vector resolutes. So from page 109 of the textbook, here are the formulas for the vector resolute and the scalar resolute. Okay, so looking at 1A, I'm interested in the unit vector of A. So the unit vector A will be A divided by the magnitude of A. The magnitude of A will equal the square root of 1 plus 4 plus 4, which is 1/3, so it's going to be 1/3 times A, which is I, plus 2J minus 2K. That's the unit vector of A. The unit vector of B is going to equal, the magnitude of B is going to be the square root of 3 squared plus 4 squared plus 5 squared, root 50, which is the square root of 25 times 2, or 5 root 2. So 1 on 5 root 2 times 3i minus 4j plus 5k. That would simplify to 1 over 5 root 2 times root 2 on root 2 would be root 2 on 10. So root 2 on 10 times 3i minus 4j plus 5k. Okay, in part B, find the scalar resolute. The scalar resolute of A in the direction of B will be A dot B on the magnitude of B. Taken from the textbook, there it is. So it's going to be A dot B, which will be 1 times 3 plus 2 times negative 4 plus negative 2 times 5 all over 5 root 2, which will equal 3 minus 8 minus 10 on 5 root 2, which equals minus 15 on 5 root 2, which is minus 3 on root 2. Or, rationalising the denominator, on root 2 times root 2 on root 2 is negative 3 root 2 on 2. Either of those will be the scalar resolute of A in the direction of B. Find the vector resolute of A parallel to B. So now we're doing the vector resolute. So if I've got A and I've got B, I'm breaking A into a component that is parallel to B and a component that is perpendicular to B. And that's going to be the vector resolute of A in the direction of B, which will be this rule here, which is A dot A over B dot B, B. A dot B over B dot B, B, which is the same as A dot B on the magnitude of B squared times B. I know A dot B equals negative 15. So it's going to be negative 15 on the magnitude, so 5 root 2 squared times B. So negative 15 on 25 times 2, which is negative 15 on 50, which is negative 3 on 10 times B, and B is 3 minus 4, 5. And that is the vector resolute. Looking at B part 3, I want the vector resolute of A perpendicular to B. Okay, so I now have A. I've broken A into a bit that is in the direction of B, and that's this here. So that is minus 3 on 10 times B. And now I'm looking for this one here, which will be find the vector resolute of A perpendicular to B. So if I call this C, C is going to equal minus 3/10 B plus A. Adding two vectors together, going from here to there is the same as going back here and then up there. So it's going to be 3/10 times B, which is 3I minus 4J plus 5K, plus A, which is 1, 2, negative 2, I plus 2J minus 2K. So piecing all of this together, putting them all over 10, I get here, which can be simplified to equaling 19 on 10 in the I plus 4/5 in the J minus a half K will be the vector resolute perpendicular.